is recognizing and extending arithmetic sequences. That's that list of numbers. So if I said 1, 3, 5, 7, the next thing you would say is 9, 11, right? We're counting the odds, adding 2 each time. We're basically identifying patterns, in other words. So we're going to find ways to identify patterns and then verbalize those patterns as well. So the thing, when I say sequence, you should think a sequence of numbers. So let's do a few of these as just practices. We'll extend each one of these sequences 2 more. So if we have the numbers 1, 3, 5, 7, I already said this one, so I'm going to write it down, 9, 11. We're just simply adding 2 each time, right? We're counting the odd numbers, but we're adding 2 each time. So the pattern there is that we're adding 2 each time. The next sequence, 7, 4, 1, negative 2. What's happening here? We're subtracting 3 each time. So our next number would be negative 5. Subtract 3. Negative 8. We're subtracting 3. Okay? 2, 6, 18, 54. This one's a little different. What's happening in between each one of these? We're multiplying by 3. So 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. So 3 times 54 is like 162, I think. Let me double check that. So as I extend my patterns, I might need my calculator so I can double check things. Oh, 162, I was wrong. And then I would multiply the next one by 3. 486. Okay, so in between each one of them, we're multiplying by 3. Multiply by 3. Okay? On the next one, we have 1, 4, 9, 16. What's happening here? I'm going to analyze a few possible solutions, and you try to figure out what we're doing. Okay, this is the first term, second term, third term, fourth term. 1, 2, 3, 4. Okay? So in between the first 2 terms, there are 3. Add 3. In between the second 2 terms, it would be add 5. That one is adding 7. So do you see a pattern? We're adding the next odd number, right? So that's one way of analyzing this. There's another way. I'm going to give that's 5 terms. I'm going to get the 6th term without adding anything to it. Watch this. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. Okay? But your pattern would still work. Plus 11, right? So sometimes we might recognize different patterns, but they're still patterns regardless. Okay? So if I want to verbalize how I'm going to say that what this pattern is, I'm adding to the previous term, I'm adding the next odd number. Adding the next odd number. Okay? If I wanted to say what I did on the second time I was explaining my pattern, I'm simply squaring the number of the term. So 1 times 1 is 1. 2 times 2 is 2. So 3 squared, 9. 4 squared, 16. 5 squared, 25. Questions there? Okay. Of these sequences above, okay, there are 2 special types of sequences called arithmetic sequences. Arithmetic sequences, this is where we need to start developing our definition, is a sequence that has a constant difference between 2 consecutive terms called a common difference. So let's write down common difference. So literally the common difference is just that. It's the difference between each term. So a constant difference between each term. Let me rephrase that. It's a constant difference between terms. And add a little note, this has to be consecutive terms. So it has to, you can't say term 1 and term 5. You have to say term 1 to term 2 to term 3. Okay, so looking at these, this one had a constant difference. This one below it had a constant difference. Now this one, it isn't a constant difference, it's a common multiple. So only these 2 are arithmetic. So arithmetic sequences, we're going to write our definition of that, is simply a sequence with a common difference. And I'm going to abbreviate this so that you guys can start getting used to it. Common difference, okay? So common difference, CD, common difference. So when you get to do this on the test, if you write CD, I will know what you're talking about. Because they'll ask you, what is the common difference? Or is there a common difference? Okay? So the common difference in the first one was positive 2. The common difference in the second one was negative 3. Okay? We wouldn't just say 3. We have to state whether it's positive or negative, so negative 3. Okay, any questions thus far? There we go. All right, let's go to example 1 then. These can go kind of quickly. On example 1A, we have 7, 12, 17, 22, and it wants us to find the next 2 terms. So this is what I would write down on my paper. I'd write down exactly this, and I'd make sure I double space so I can start to do my work. What is the difference between the first and the second one? 5, so it's adding 5, right? Next 2, is it 5 again? So does it have a common difference? So what is our common difference? Common difference is 5. Good. So the next term is going to be, and then 32. Good. Okay, any questions there? There is a long drawn out way. If you want to see it, look in your book. The simple way is just to write it in, right? And then just follow it along. Okay, on B, we go 3, 6, 12, 24. Sorry, I wrote 12 again. Find the next 2 terms. Oh, I should have asked you. On A, is A arithmetic? So yes, it is, right? Okay, let's look at this next one then. 3, 6, 12, 24. What's happening? So multiplying the previous term by 2. So what is the next term going to be? 48, and then 48 times 48. It's going to be 96. 48 times 2 is 96. Good. So is there a common difference? What is it? That's not a difference. That's a common multiple, right? So this has a common multiple, but it doesn't have a common difference. So the common difference would be none. There's no common difference. So therefore, is it arithmetic?
No.
No. So that's a real simple question to ask yourself. Does it have a common difference? Yes or no? Your answer for that one will also tell you whether it's arithmetic or not. Any questions there? Okay, good deal. All right. So there's a way to write this, and I don't want to confuse you guys. So at any point, you have to tell me, I don't know what you're doing there. Okay? So we want to make sure that we clarify this, because you're going to see this a lot in the coming days. So let me give you a definition first. Arithmetic sequence formula does this, and it kind of is drawn out because it wants to define a general term. So it says that the next term is going to be the last term plus the common difference. Okay? So a to the n, let me define what a to the n would mean. A is just a term in the sequence. Okay? So let's define a, I guess, first. A is a term in the sequence. A term in the sequence. Okay? If I said a sub 1, that means that's the first term. But yes. So a sub 1 is just the first term. So when I say a sub n, I'm talking in general. It's whatever number term that we're on. Okay? So when I say a sub n, I'm talking in general. It's just a nth term. It's whatever they're asking for. It's a general whatever term they're on. Okay? So when we talk this formula, it's whatever term we're on equals the term before it, n minus 1 would be the term before it, plus d, which would be our common difference. Okay? And just in case we forget, I'm going to define what n is. N is the term number. Okay? I'm going to make this little arrow to show you where it goes, where you normally see the n. Okay? So, sometimes they'll give you a problem and they'll say, we need to find the I don't know, the fourth term or something. And they'll give you the third term, so you just need to find it. Okay? So, let's do this arithmetic sequence. If we had 7, 11, 15, and 19. And it said write down the arithmetic sequence formula for this. We need to first find the common difference. What is the common difference? It's adding 4, right? So I'm going to write down this formula. I'm going to go a sub n equals a sub n minus 1 plus the common difference. So as I find things out, I'm going to plug them in. So the first thing that I found out was the common difference. So I'm going to plug it in. Common difference was positive 4, so it remains plus 4. If it was a negative number, it would be minus. Okay? So I plug it in. Then, as I continue, I want to identify which term is which term. So here, this is the first term, so it's a sub 1. This is the second term, so it's a sub 2. This is the third term, so it's a sub 3. And this one would be a sub 4. If they told us that we need to find a sub 5, so this is the question, find a sub 5. So I would plug this in because this is what I'm trying to find, what I want. Okay, so I would plug that in, a sub 5. I don't know what it is yet, so I'm just plugging in, a sub 5, equals a sub 5 minus 1. What is a sub 5 minus 1? It's a sub 4, right? What was a sub 4? 19, so I just plug her in. And then add my common difference, which is 4. And then my answer would be, if I'm adding 4, what's my answer? 23, right? Yes, it's a long drawn out while you add 4. We add to this definition later, so we need to start getting used to it. Okay? So the next term would have been 23. Now if it had asked us to find a sub 6, we would have had to find a sub 4, then a sub 5, and then a sub 6. Okay? So they gave us a sub 4, so that would have been a simple one to go. Okay. So that is the arithmetic formula. We might need to add that in. Okay? Right here. Hopefully we don't use that one as much, because I'm not a huge fan of it. But the next one is called the recursive formula. Now I do kind of like the recursive formula a little bit better. So let me make sure that that's the right definition that I'm looking for. Oh, no. No, it's not. So they'll also call this the recursive formula. That's not the one that I was thinking it was. The arithmetic formula, they will also call it the recursive formula. So add that to your... There is a formula that will allow you to find any term in a sequence, whether it's 100 away or 50 away or 2 away. It'll allow you to find any of them, and I like that one. I thought it was a recursive, but my definitions are mixed up. So we're going to use what they gave us. So using this formula, the a sub n equals a sub n minus 1 plus the common difference, we're going to find whatever they ask us to find. So here we go. Use recursive formula to find the first 4 terms of an arithmetic sequence, where a sub 1 is negative 2. So what's our first term? Negative 2. and then our common difference is 7. So I can plug that into my recursive formula now. I'm adding 7 each time, right? So the easiest way to do this, if they tell us what term it is, we can simply do what to it? If the common difference is positive 7, what can I do to find my next term? I just add 7, right? So to find my next term, I plug in its previous term, which would be negative 2 plus 7. So that gives me what?
5.
Positive 5, right? And then I take that term, which is my term before a sub 3, and I would plug in 5 plus 7, which is 12. Okay, this is just, again, a long drawn out way to do this. And then it's 12 plus 7, which is 19, and that's our last term. Ooh, I almost ran out of space. So the answer would be those 4 terms. And you need to be familiar with this annotation: a sub 1, a sub 2, a sub 3, a sub 4. Okay? Alright. Try to do that one as fast as I could. Now this is the one I like. Alright. Finding the nth term in a sequence. So finding the nth term in a sequence allows us to use this kind of formula. A sub n, this still stands for the same thing it did before, it's whatever nth term it is, equals the first term, a sub 1, plus the number of terms we are, minus 1, multiplied by the common difference. Okay? So remember, I'm just going to write this underneath. This is the number, the term number. This is still the common difference. This is the first term. And this is the term we want. We're trying to find. Most of the time, it's the one we're trying to find. Okay? So I like this one because it allows you to find any term in the sequence. So on example 3, part A, it says, use the rule a sub n equals 6 plus n minus 1 multiplied by 2. So I'm going to ask a few questions. We're going to see if we know what each one of these are. So what is the 6? It's the first term in our sequence. What is the 2? Okay, and what is a sub n? What we're wanting to find. And what is n? The term number. So it goes on to say, it says find the 4th and 11th terms in the sequence. So in order to find the term we're wanting, we have to plug in the number of terms. So the term number that we're going to find first is 4, and then we just solve for the rest of it. So I just solved that. Use order of operations. 4 minus 1 is 3. So now I have 6 plus 3 multiplied by 2. What's the next thing I do? Multiply. 3 times 2 is 6. And then we have 6 plus 6, which would be 12. So the nth term, remember, if I wanted to plug this in because I knew what n was, I would have said a sub 4, right? So everywhere that I put a sub in, I could have put, because I knew what term I was looking for, a sub 4, a sub 4. Okay, so a sub 4 is 12, or the 4th term is 12. Okay, now it tells us to find the 11th term. So I'm going to find the 11th term, a sub 11, by plugging into the same formula that I did before. So it was 11 minus 1 this time. Close, and then multiply that by 2. So we start to follow down. 11 minus 1 is 10. Good, and now we're left with 6 plus 10 times 2, so it'd be 20. And then we have 20 plus 6, which is 26. 26. Good. So the 11th term equals 26. Questions? All right. So this starts to build on it. So remember our recursive formula, a sub n equals a sub 1 plus the number in the term minus 1 times b. Okay? So they give us a sequence. They say 3, 11, 19, 27. Is there a common difference?
No.
So the difference between this one is 8, right? What's the difference between this one? So there is a common difference. What is it? So the common difference is 8. So is this an arithmetic sequence? So can we use this formula? Yes. So I'm going to plug that in immediately. 8, right? So I've now got a new formula of n minus 1. Do I know the first term? It's 3, right? I just take it from this guy right there. So the first term was 3. So now I have my formula, right? I've plugged in everything that I know. Now I need to answer the question. It says find the 10th term in the sequence. So I'm going to find the 10th term, and I'm just going to plug in everything that I know now. 10 minus 1 multiplied by 8. Oops, sorry, I forgot to put a plus sign there. So now I just start to follow through with order of operations. So 10 minus 1? 9 times 8. So we are left with 3 plus 72. What is it? 75. And we're done. The 10th term in the sequence is 75. Yes, you could continue the pattern by adding 8 6 more times if you wanted. However, this does not help you understand the formula, and it does not help you get from point A to point B. And when we get to part C, where there's a fraction, you're going to really, really, really want to know how to do this. So on C, it says find the 10th term in the sequence, and it says 1/4, 2/4, 5/4, and 7/4. What's happening in between each one of these? We're adding a half. Would you agree? Everybody agree? Oh, I wrote that down. I did. I'm so sorry. So, yes, we're adding a half, but that's also called 2/4, right? So we're adding 2/4. So our common difference is 2/4. Reduced is 1/2. Okay, just to clarify that. So we're adding it, right? Every single time. So I need to start with my formula. My a sub n equals the first term, which is what? 1/4, added to my number in the term, minus 1, multiplied by 1/2. And then I can follow this. So the 10th term, we're going to start to plug it in. So a sub 10 is equal to 1/4 plus 10 minus 1 again. And if you want to, when you write that down, obviously you can just write down 9. I think y'all guys can all subtract 1 fairly good. So go ahead and do it. So a sub 10 equals 1/4 plus 9 multiplied by 1/2. So when I do that multiplication, what do I get? Leave it as a fraction. Let's leave it as a fraction. Top times top and bottom times bottom, I get what? 9/2, right? Now why do I want to leave it as a fraction? Because I'm adding a fraction, right? So I'd leave it as a fraction because I'm adding a fraction. What's my common denominator going to be?
4.
It's going to be 4, right? Because this one cannot reduce. So this one has to be changed by a multiple of 2. So now I'm left with 1/4 plus 18/4. Final answer? 19/4. Can I reduce it? You can? No, I can't. Okay, so that is my final answer. The 10th term is 19/4. Any questions? All right. Let's see what we do on example 4 then. Example 4 says it's the application of a seating for a reception. The first table at the reception will seat 9 guests, while each additional table will only seat 6 more guests. So write the rule for this situation. What is the first term, the first table? How many is it going to seat? It's going to seat 9. It says that they can seat an additional 6 more guests per table. So if I'm seating 6 more, then my next term would be what? How many total people? 15, right? So my common difference is going to be what? 6. So my common difference is 6. And I can start my formula. It wants me to find, write a model. So we're going to write a model for this situation. So we'll write our formula. So a sub n equals our first term of 9, and then our whatever term minus 1, close that, multiplied by our common difference. I always forget to put that plus sign. I'm not sure why. Make sure you don't forget your plus sign like I did. Now it says use the rule to find out 10. I feel like we're getting too comfortable with 10, so I'm going to change it up. Let's find 20. So we're going to find the 20th term. So it's a sub 20. Then we have 9 to start with, and we 20 minus 1 multiplied by 6. So our 20th term in the sequence is going to be 19 multiplied by 6. Somebody give me that if you would. 114. So now I have 114 plus 9, which will give me 123. So I have a total of 123 on my 20th term. But to translate this into an answer, 123 guests can be seated at how many tables? 20 tables, right? Because I changed it to 20. There you go. Questions?